welcome to everybody. Just to get started, welcome to the UAS Cluster Initiative Lab to Business pitch session. We're here to present some of the latest technologies from labs, specifically today NASA Armstrong, that are Armstrong Flight Research Center, that are available for business to business for commercialization. And if you're looking to start a business or a new product line, you'll hear about 3 technologies today that you can license from Armstrong, or work in research partnerships. And you can let's see, where I lost my thing. Oh, but first, to get going here, we're going to hear from the UASCI, or Cluster Initiative Executive Director, Craig Mahaney. And Craig, it's all yours.
Okay, thanks, Jack. Yeah, welcome everybody. Appreciate you taking out a little bit of time today to listen to these 3 technologies. Special thanks to Brian and NASA Armstrong for taking the time to present. And yeah, so I just wanted to give a quick sort of overview for those of you who don't know about the US Cluster Initiative. Some of you do. I do recognize some names and faces on here. So my name is Craig Mahaney. I'm the Executive Director for the UAS Cluster Initiative. I came on board back in January, spent most of my adult life in aviation through various, was air traffic control in the military, and then worked for the FAA for 16 years, did some time working on Capitol Hill for the Senate. And so I'm happy to be here. And so for the UAS Cluster Initiative, what it is it's a program sponsored through private industry and a contract with the U.S. Small Business Administration. And really our mission is to kind of accelerate the growth of both unmanned aerial system and advanced air mobility in this region, specifically Oklahoma, but we do have a national presence as well. And we do that through a series of different projects, and we focus on entrepreneurial ecosystem building. So the 3 ways that we build the ecosystem, one is through startup mentoring and some consulting work that we do. Part of that is the technology licensing support that Jack provides for us. And a piece of that is this pitch session where we scour national labs through universities and the federal government, find technologies that are specific to both UAS and advanced air mobility. We want to find ones that can be commercialized pretty quickly so entrepreneurs can jump on board, start a business, or an established company can use those to advance one of their current products. So that's why we do these pitch sessions. It's part of one of the deliverables that we provide under this contract. We also do a lot of convening. We do a lot of networking within the industry, both UAS and AAM. Some of that's through different kind of demo days where we connect industries that may not be using UAS, like maybe oil and gas and the cattle industry, ranching industry, who are just starting to use those technologies. We try to find different industries that could use these new technologies, and we connect them to try to create business partnerships. So we do that. And then we also focus on access to capital for startups. So we work with regional venture capital firms, worked with national angel groups to try to connect early stage pre-seed capital to some of these startups in the industry. And primarily we do that through what I call the UAS Angel Network. And that is part of this program as well. And we do pitch sessions to investors and let founders pitch to those investors, usually on a bi-monthly basis. So those are just a few of the things we do and why we're doing this pitch session. And with that, I will throw it back over to Jack.
Okay, thank you, Craig. So now I want to introduce Brian Bugard. I'm sorry, I forgot to ask. Did I get that name
close
right?
Enough.
Oh, close enough. Okay. So Brian is a technology transfer administrator at NASA's Armstrong Flight Research Center in Southern California. He has experience in small business ownership, project management, technology transfer. He holds a BS in business from California State University, Sacramento, an MBA from CSU Bakersfield. And so Brian's going to start here. He's going to be doing a lot of the presentations today by giving an overview of NASA Armstrong and their research. So let's see, go ahead and start sharing the screen, and you can take it there, Brian.
Sounds good. Thanks, Jack. Thanks again for having me here. Everyone, thank you for attending. Let me know when you can see, Jack, when you can see the whole screen here. I think we'll be ready to take it away.
I can see that.
Okay, sounds good. All right, so we'll get started with just a quick overview of Armstrong Flight Research Center. For those of you who don't know, we're kind of out here in the high desert in Southern California, located maybe about an hour and a half or so north of Los Angeles in a straight line, formerly known as Dryden Flight Research Center. We've been here in one shape or another since 1946. And we have kind of a unique mission among the major NASA centers, of which there are 10. Many of the centers focus primarily on space activities. We are primarily an aeronautics center. We do assist with some of the space programs, but really, our goals are kind of a few-fold here, and I've got them listed on the screen. But our real objectives are to perform flight research and technology integration to revolutionize aviation and pioneer aerospace technology. We validate space exploration concepts, and we conduct airborne remote sensing and science observation programs. So just kind of a little bit of an overview here. Really one of the things that sets us apart from the other center is the fact that we're next to a 44 square mile dry lake bed. We have access to more runways than I think maybe any other location in the world in such a clustered area. Obviously, we partner with the Air Force, so we make use of the long runways that are built, and then the dry lake bed really gives us a great foundation for a variety of flight testing programs without endangering activities on the ground. Some of the ones in the past you'd probably recognize: the X-15 at the F-8 supercritical wing here on the right, the X-43, and some newer ones which I'll talk about in a minute. But really all of that has kind of boiled down to we've had a group of people here cycling in and out for such a long time that the processes and procedures to conduct quality, safe flight testing programs have been really developed at Armstrong and Dryden. We have platform aircraft which obtain an incredible amount of science data. We have a team of people that their skills and capabilities are a real asset to the agency and to the industry abroad. So what do we really do? So we have our primary programs, which I'm sure some of you have seen: the X-57, the distributed electric propulsion airplane. We have the X-59 Quest, which is formerly known as the low boom flight demonstrator. These are two X-planes kind of harkening back to the real heyday of the X-plane program, really designed to push the envelope for flight testing and for paving the way for industry and commercialization to come in behind and really take these technologies and pick them up and run with them. Integration of developmental systems is huge. We have a number of support aircraft that serve as test beds for a variety of different science programs. We have, unfortunately, the soon-to-be retired Sophia, the 747 Short, has been a great platform for astronomy. We've got a Douglas DC-8, a couple of ER-2s, a handful of other aircrafts that serve as science platforms. So, really focusing on advancing science. And what's interesting about the technologies we'll talk about today is some of them, our engineers are working on these programs, but either in spare time or in conjunction with these programs, really they're always developing new innovations, which they've kicked over to the tech transfer office, and we help to, identify and commercialize them, move them forward. So, and I'm going to skip this because we just talked about it. So, Jack, are we good to move on to the first? Yeah,
I was going to say thank you. So, yeah, you're going to start in with the overview of the magnetic field sensors, and just a reminder for everybody, anybody, if you have any questions, post them in the chat. We'll depending on the traffic and everything else, we'll do some combination read and also open it up for people to ask them themselves. So, yes, go ahead.
Okay, sounds good. So our first technology is a magnetic sensing technology. And before I dive into the specifics of it, it's important to talk about kind of the technology platform that it's based on, which is the FOSS system. Stands for Fiber Optic Sensing System. This is probably our most prolific technology package at the center. And what it is it's a low-cost, simple technology package that monitors a host of critical parameters in real time. So what it is you have like a strand of optical fiber. And what they've done is they've implanted fiber Bragg grading sensors into the fiber, and you can embed them as close together as about 1/4 of an inch. And they do those in intervals. And what they do is when like a distributed laser is pulsed through the fiber, the sensors will reflect some of the wavelengths and transmit all the rest of them through. And what you get is kind of a sensor package where many different parameters can be measured at high spatial resolution and in very real time at a pretty high hertz as well. What helps to, well, it doesn't help, it enables the discernment of these different activities are algorithms that were developed by the FOSS team here. And we have quite a handful of people that have worked on it and continue to work on it over time. But you get position deformation, readouts, stiffness, operational loads, strength and stress measurements. There are cryogenic tank level sensing solutions using this technology. And then of course the magnetic field sensing technology as well. It's certainly one of those things I feel like every time I talk to somebody about it, there's a new application. And if anything, if the magnetic sensing doesn't necessarily pique your interest today, we'd still love to discuss, other applications. We get incoming license applications for this all the time. There's a lot that you can do with the program.
Yeah, Brian, this is kind of an addition to what we scheduled to talk about, but it's still part of it all, and it's a very nice platform technology that you can do a lot of things off of, right?
Absolutely. Yep. Let's dive into the magnetic sensing. So the magnetic sensing application of this technology operates a little bit differently than the rest of the sensor suite applications. So what they've done is the FPG sensors that they've embedded into the fiber, they're not measuring like a mechanical change necessarily. What they've done is they've implanted ferromagnetic nanoparticles into the fiber that enable a direct coupling with the external magnetic field. So it allows for very quick, very high spatial resolution mapping of magnetic fields. The real benefit to this is that you have a very flexible way that it can be implemented. Fiber is obviously very flexible. You can route it in a number of different ways. You can route as long as a 40-foot stretch of fiber. So if you're trying to come up with a custom way to implement this onto a UAV, for instance, you have a lot of options in terms of how you put it together. And it's a lighter package than a lot of the existing electronic magnetic field devices. So I want to go over some applications. This is by no means an exhaustive list, but there's clearly a homeland security explosive device detection application here. You have navigation, aerospace observations, altitude sensing, GPS backup as potential applications, electromagnetic receptors, antennas, mineral exploration, oil and gas, geophysical, archaeology, quite a number of areas that this can be implemented. In the interest of full disclosure, it's a low TRL. A number of our technologies at the center end up, most of them are, maybe in the 3 to 4 range. That's because we've got a, very tight group of people, many competing priorities. And, even though there's a lot of potential in a number of technology areas, sometimes other things can, countermand what the engineers may want to work on. This has been, we don't have like a currently active working prototype, but the technology, there is a large FOSS team. And if anyone is interested in picking it up and developing it into a commercial product, there's certainly a lot of technical expertise available at the center, which isn't always the case. Sometimes people come up with innovations and they move on, they retire, and some of that PI wisdom is lost. So Jack, I guess this is probably a good place to take a break and see if there are any questions.
Yeah,
from the
and so quick, I wanted to add to that. That's one of the advantages of working with a lab is you can, you can tap in and branch your own, company's research into their expertise and collaborate on a lot of these things when you're developing, new technologies and stuff like that.
Yeah,
Um,
that's a good point too, because many of the inventors, they have a vested interest and they really are eager to see companies pick things up and help develop them, because they, if there are more than 24 hours in the day, they probably want to be doing it on their own. But anything that can be done to to advance things further, and sometimes they even turn into joint ownership agreement type collaborations. Those are always welcome to us.
and so, real quick, a status on the patents on this technology?
Active one patent for this,
Oh,
held by NASA. There's not, currently a lot of development going towards it. There is a significant amount of development on the FOSS platform, but not a lot of focus on the magnetic field sensing.
but some of the
portion
FOSS platform stuff is complementary to, I mean, they could be kind of overlapping in some of the scope, right?
That is accurate. Yep.
Yeah. Okay, let's see. Open it up. Anybody out there, feel free to unmute and ask a question.
Hello, thank you for that. Coming from a non-engineer, if I were using this in UAV development, um, how much and what components would I be connecting to best optimize this tech?
So, to my knowledge, and you're going one non-engineer to another non-engineer, so you're in good company. My understanding is, if you're going to have a system that's operating on a UAV, you're going to have the fiber strands that are on there, and there'd be a very low weight interrogator, which is what shoots the distributed laser down the fiber optic strand. So then it pulls all the sensors, and then it comes back and reports its information. Does that answer your question?
And you would need, I mean, this would then hook into your, data information management system for, whatever other sensors and things like that are going on. Now, I mean, if that's the purpose of the UAV is to fly around and map magnetic fields or something like that, then you'd be, you'd have a system to set up. And that's where, being at this point, the TRL, I would imagine is kind of somewhat optimal, because you still have to gather, based on the application, you still kind of have to put together what the next pieces are, where you gather information, things like that.
Yep.
Let's see, any numbers on the magnetic field strength levels that can be detective at what range? And does it pick up noise from ferromagnetic articles in the vicinity?
Those are good questions. I don't know the answers to them off the top of my head, and I also don't know. Jack, are you keeping track of who's asking? Because I can't see anything.
Let's see. I think we have that in the list. So
Okay.
and we can gather this up and send it back out to folks. Yeah.
Yeah, I'm not sure if any members of the FOSS team made it onto this call. I know they're super busy, but if nobody's on, I'm guessing nobody's on, then what I can do is I'll get with them, and whoever asked, I'll get the answers back to you either directly or through Jack. Those are good questions.
And I expect some of that would be kind of making this a dialogue here. Some of that would be tested, because if you did strap it to a UAV, the nice thing about UAVs is you can get low or lower, and the nice thing about fiber optics, they are very lightweight, as opposed to a lot of times you measure magnetic field with wire and coils and stuff like that. But
Sure.
but yeah, you could fly it at different heights and then actually figure out what kind of, you still have to kind of resolve some of those answers in real practice for your application.
Yep.
And yeah. Any other questions on this one? Okay. Thank you on that one, Brian. And I guess we'll move to the next technology.
Sounds great. Okay, next up, we've got our wireless gateway technology. So this is an innovation that's pretty darn new. And what it is it's a wireless technology platform that kind of serves as like a gateway. So it's designed around, commercial off-the-shelf software-defined radio. And what it does is it acts as a gateway that can, serve as the conduit between wireless sensors that you may want to integrate into an aircraft or a spacecraft and the aircraft and spacecraft systems. In the past, of course, any integration of new sensors, you've got airworthiness review, you have physical cabling, which you have to run through the airframe, which is not always an easy thing to do. I mean, we do integrations of new experiments and new sensors on our support aircraft, and the aircraft can be grounded for months at a time, depending on the complexity of what's going on. So this is a pretty cool program. So the software-defined radio acts as a gateway, can communicate on a number of different communication protocols, 5G, Bluetooth, 2.4 gigahertz. And the real value of it is that if you have sensors or you have telemetry systems or avionics systems that you want to incorporate into a new into an aircraft, it can be done. If you have the gateway in place already, then those systems can be integrated very seamlessly. The hub is manufacturer and kind of function agnostic in that respect.
And Brian,
yes.
So yeah, and real quick. So I guess as part of that is if you had a vehicle or an application, either in a drone or a UAV or something like that, it can make your missions very modular. You can swap out sensor packages very, very quickly and easily.
Absolutely, yeah. If you had like a microphone or something that you wanted to put on a UAV and it had a wireless transmitter, you could put it on, and then for a subsequent flight, if you wanted to fly something else, you could take the microphone off and put on a separate sensor of some sort without clamping wiring down, without worrying about the additional weight. The real benefit of this, from a weight perspective especially, is maybe getting into the larger UAVs, where you're fighting for payload space, you're fighting for endurance. Anything that can be done to reduce the overall payload on board is certainly, it's something we always strive forward here on our aircraft. I mean, some of our planes have hundreds, thousands of pounds of wiring in them, and anything that can be done either means you can fly additional science or you can fly that science for longer. These are all benefits. So I'm going to jump down to the application. So this actually has, I'm talking about, I know you're all interested in, obviously in aircraft, UAVs and such. There's certainly an aeronautics component, aerospace. There's also potentially an automotive component. There's systems health monitoring in long-term storage. There's also an industrial component, maybe not as applicable for this group, but in industrial automation, this has a lot of promise, where you have complicated assembly lines, complicated systems of equipment. If you want to be able to swap sensors in and out, even if it's from a maintenance perspective, bringing things in and out quickly without having to rerun cabling is really a significant advantage. Now, this technology, again, it's a little bit of a lower TRL. We had a prototype that was developed when the innovation was patented. It's not how do I phrase this? It's not facing an incredible amount of development at the moment, but we in the Tech Transfer Office are working on a couple of collaborative efforts to see it increased in TRL. At this point, software development, having the software-defined radio work with a variety of sensors in a more efficient manner is kind of what's on the docket in terms of what's being developed. we're planning on, we're planning on flight testing this gateway on one of our support aircraft. We have a handful. Well, we just got more. We have many F-18s. We've got some F-15s. We have a T-34. We have a couple of King Airs. We're planning on flying this at some point on one of those aircraft. And really, at some point, it's going to be about wireless gathering of telemetry information from aircraft and being able to quickly integrate science flights onto an airplane without having to integrate maybe that science package with the airplane's own systems. But our PI is still here. He's still working on this technology and in the little spare time that he has. But yeah, that's the overview of this technology. Jack, I'm open to open it back up for questions.
And kind of making one of the real unique things on this to me is so a lot of times, you know, a radio is defined in a hardware. So the frequency and the protocols and what it's doing is defined in a hardware. This is a software defined radio. So it, you know, you just upload the new set of code and then it can adapt to the new, you know, the frequencies and the protocols that of whatever element you're trying to talk to. So kind of going back and then we'll open to questions. But again, how many, you have a number of patents on this, right?
We have one. We have
just one. Okay.
Yep.
And any other active ones in the mill?
No more active patents at this point. It's just going to be down to the software.
Okay.
The software development of it, but yeah, you know, the ability that's the whole thing for us, especially is, you know, and I see a lot of value for this in the unmanned community as well. But anything that can cut down on the amount of time it takes to deintegrate and reintegrate new technologies on any sort of aircraft, you know, any weight reductions resulting from those, anytime you don't have to, you know, mess around with the existing systems on aircraft is real big. I'll say, I don't want to name the university, but we were working with the university, and at some point, the plan is they have a kind of a boundary layer sensing device. The goal is to affix that to one of our aircraft and use this wireless gateway and have it transmit information to it. And it's kind of in its own self-contained, self-powered pod. So they have kind of a proprietary way of, I don't want to use the word gluing it to the airplane, but in essence, it's basically being, you know, glued / taped to the airframe. There's no power integration. You know, in theory, it's a 48-hour integration that we can go fly. So I could see there being real value to it, you know, for the UAV community as well.
Okay. And so open it up here. Anybody online have any questions they want to ask?
Hey, Brian, I had a couple of questions, but Suman already posted some questions to the chat, so I'll let you answer his first, and then I'll ask my questions.
Okay.
So it says on the wireless gateway, what is the frequency that is being used?
Based on, yeah, that's based on the whatever software defined radio you have. So I know some will operate up to a gigahertz, some will go, you know, higher. It's all based on that range. So if you have you know, it'll end up being the application that kind of begets which sort of radio you purchase. But that's the nice thing, is it really is whatever the hardware capability is that is chosen.
And the nice thing is configuration. I see this because I saw this for more spacecraft applications, because once you get the radio up there, you can't really change it too easily. Right. But with the software, you can just reprogram it and it can, you know, go off to a different frequency. To see any issues with non-line of sight environment, you mean like blockages, or it says like bulkheads?
Gotcha. Not that we've encountered. I would imagine line of sight is relatively important for this application, but again, it's gonna somewhat come down to the hardware that's chosen. I think in most of the use cases for us, it's gonna be line of sight. But then I suppose, you know, integration into an existing airframe you're gonna need to take some of those things into account. You know, if you're having say the radio is placed in kind of a central position in the aircraft or the UAV, if you have sensors in different, areas, having, transmission stopping materials between that and the radio, I could see there being an issue, but it'll depend, I think, probably on the frequency. It'll depend on the communication method. If it's like Bluetooth, I know Bluetooth is relatively weak. So I could see there being some things there, but we haven't run into any problems yet.
Yeah, some of that just depends. I mean, in general RF fields, depends on the frequency and how, what the structure of the obstruction, so to speak.
Sure.
Crately, you had something?
Yeah, hi Brian. This is Crately Epperson with Vigilant, and we have worked with Janaea and Sam in the Armstrong Tech Transfer Office. So.
Yep. I think I emailed you a couple months ago about something with ADSB, if I'm not mistaken. I recognize.
Oh yeah, I think you may have. So I've worked with SDRs and worked with them to do telemetry. And so I guess my question is kind of what is the patent coverage just in general, and what's the innovation? Because I know how to we've used off-the-shelf SDRs and just use the API that comes with them to program them to do specialized things. In aviation, actually, as it turned out, just because that's what we were doing. So I'm curious about kind of what the innovation claim is here, so I can understand how to implement something like this.
I believe it's in the software, the use of the software application that was written for the prototype. That's a good question. Let me check on it and get you some more specific information than that.
Okay, all right. I am happy to look it up if it's published on your website as well.
Okay. It is. Yeah, absolutely. Yeah, I'll get you. I know the patent portfolio can be a little bit of a rabbit hole in some respects, but yeah, I'll follow up with that with you and let you know.
So that's a question of what's the uniqueness of this SDR approach. And then I see back, did you say you've already flown this on an F-18 or you've flown it on other vehicles?
No, we've had a lab prototype, but we have not
Okay.
flown yet on. Yeah, the plan is going to be to fly it on some of our support aircraft fleet.
Okay.
Yep.
Any other questions? Okay. Well, having that, I guess we will move right along to the third one in the list.
Sounds good. We'll move to a higher TRL for once out of these three. So this technology, it's an auto-tracking antenna platform. This is certainly necessity is the mother of invention use case here. What it is a number of years ago, some of our engineers were trying to look for a platform to mount a handful of antennas on that wasn't going to break the bank and was going to achieve what they needed it to do. And they really couldn't find anything. There were, things that could mount one antenna, and then there were, military application platforms that could mount, a number of them, but they were extraordinarily expensive. So they designed this, and what it is, it's a low weight, low cost platform. It can be carried into the field by one person. It's continuously rotating, it's small, and it can accommodate up to 58 pounds of antennas, transmitters and receivers. Runs off 120 volt power. It's got a 20-mile, kind of line of sight tracking capability using, depending, of course, on what type of antennas are on there, multiple radio frequencies. They designed it using fiber optic rotary joints, slip rings. They built a functioning prototype of this that was used in a couple projects here at Armstrong. And yeah, this is certainly one of the more fully fleshed out technologies that we have. It utilizes GPS, updates quickly, has quite a handful of potential applications. This again is by no means an exhaustive list, but for UAVs and for doing line of sight tracking, surveillance, research, agriculture, really any situation where you want to mount antennas, you could probably, it's kind of an agnostic mounting platform. You can mount nearly whatever you want on there. And if you want everything to kind of track, be able to track at the same time in a very accurate fashion, this may fit the bill. Jack, to your earlier questions, we do have one patent on this. Like I mentioned, there's a fully functioning prototype that was used on multiple occasions. We have all of the shop drawings. The AutoTracking software was put together and used, and it's available for release and license. And I think we've had maybe 1 or 2 licensees of this in the past, but nobody who's taken it to real, great commercial potential necessarily. But yeah, that's a quick overview. It's a relatively straightforward technology. I think we can open it up to any questions.
Yeah, and so just to comment, I mean, so in a lot of times in government technologies, you don't see anything this packaged and ready to go very often, but
one of our few.
Yeah, this is one of them. And with all the R&D and development, and even a lot of the testing zones or regions that are going on for kind of different types of flight testing, this is kind of it's a unique type thing, but it may fit there. So let's see, and you got the most of the other questions, so open that up if there's any questions from the audience here. Anyone? Let's see. Oh, okay. We can move along here.
Okay. Yeah.
So so Brian, you're going to now cover kind of the contact information if folks are interested, right?
Yep. Yeah, absolutely. Yeah, I'll make a quick note. So this is just a kind of a map of some of the tech transfer contacts around the country. Or I didn't really mention it at the beginning, but our primary goal in the TTO office is, it's in a way to be good stewards of the technology that's been developed using everybody's tax funding, right? NASA's primary goal is not to commercialize technologies for itself. It's to, provide the, the location, the resources, the tools for our engineers to come up with great innovations, and then it's our job to get things spread back out as widely as possible to the industry and academia. We work with universities on joint research programs. We work with companies. Obviously, there's the SBIR, STTR programs, which I'm assuming many, if all of you are, if not all of you are familiar with. All of these are ways to try to get the things that we've developed, back into the hands of folks. So I encourage you, there's bottom left-hand corner, we've got the technology.nasa.gov. That takes you to our main tech transfer page. There's a patent portfolio, has well north of 1,000 different patents in there. If you're ever bored, or you want to be partially put to sleep, just start trolling through there. There are a lot of really cool things in there, and some of them may pique your interest. And if you're ever interested, in any of these technologies or any of the other ones, don't hesitate to reach out. We have very aggressive startup licensing programs that are very low cost and really designed to just give people kind of a springboard opportunity to, take something that we've come up with and improve it, enhance it, commercialize it.
And so, again, focusing on that technology.nasa.gov. So if you're wondering how to license and things like that, there's some really good videos and reference resources on how to do all that. And then you can also just, call somebody on this list, or you can even call myself and contact me through the AuSCI site and help kind of guide you on some of those things before. We have a question here. Can technologies be developed further under SBIR STTR?
Yes, they can. That's actually been a topic of conversation around here a little bit, but sometimes we get in a number of cases, we'll have folks that will apply to one of the subtopics and they will reference wanting to license one of our technologies in support of the furtherance of that subtopic. That's absolutely doable.
And I think one of the keys there is, and correct me if I'm wrong, is if before you get to, you need to talk to the proper tech transfer office about
Yes.
the licensing and rights to use it before you start applying to the SBIR, because
Yeah.
they'll double check that.
Yeah,
Right.
yeah. The one benefit, it's definitely a good thing to do. One not really a caveat, but I guess it's a supporting point, is the technologies that you see on the patent portfolio website, at least are not exclusively licensed, and that's pretty accurate across the board. Whenever it's pretty rare that we do exclusive license agreements, but if we do, we pull them from the site, or at least hide the pages so that people can't necessarily see it and say, oh, I want to do something, and then they apply and we come back and say, oh, sorry, you can't license it. But it's a good point that you made, Jack, because the more collaboration you have with us ahead of time,
Yep.
the more you can make the most of the time that's allowed under the SBIR. It's
Yep.
not an overwhelming amount of time. Some of the
No.
licenses can take a number of weeks to get going, and if you need that day one, then you're kind of behind the 8 ball. So
Yeah, it is.
point.
So, but one different slant on that, and I'm not sure exactly how this is going to fall out, but was kind of excited on this SBIR Ignite announcement that kind of came out here recently. That's going to be available. I guess there's going to be a solicitation this summer where instead of the traditional subtopics, I guess it'll be areas, but a lot of it will be focused on commercialization as opposed to meeting, some topic requirement that NASA has defined for specific technology. Correct?
Yep, that is correct. Yeah. Yeah.
Okay.
Well, that's what I have. I really appreciate you having me on to the event, and really enjoyed taking the time. And like I said, if there's any follow-up, any questions, more than happy to work with folks. And for the questions that we do have, Jack, I'll get with you, or maybe I could just copy the ones in the chat. We can go ahead and get answers to those after the fact. Go from there.
Okay. We can do that. And let's see, one last thing here, I was going to add, where is it? There is it. Just kind of a closing for that. It said your ad website for yourself, but you kind of had that on your last slide.
Yep.
There's also the contact information for Craig or myself there. And want to thank everybody for attending today, and appreciate everybody taking the time.